Question 4. This question is about S block metals. Give the full electron configuration for the calcium ion Ca2+. It's going to be 1s2, 2s2, 2p6, 3s2, 3p6. Explain why the second ionization energy of calcium is lower than second ionization energy of potassium. So second ionization energy of calcium, lower second ionization energy of potassium. Okay. Well, in calcium, the outer electron is further away from the nucleus, and it is 2 marks, hence more shielding in calcium, hence second ionization energy of calcium is lower than the second ionization energy of potassium. Outer electron is further away from the nucleus, hence more shielding. Identify the S block metal that has the highest first ionization energy. And for this topic on ionization energies, I guess you could do this like just memorize beforehand the S block with the highest first ionization energy, S block metal with the lowest first ionization energy, and do it for S, P, D, and F. For the S block metal with the highest first ionization energy is Be, beryllium. Give the formula of the hydroxide that is least soluble in water, magnesium hydroxide. MgOH squared. It says formula, doesn't say name formula. Magnesium hydroxide is the least soluble in water. And then we've got question 4.5. A student added 6 centimeters cubed of 0.25 mole per dm minus cube of barium chloride solution to 8 centimeters cubed of sodium sulfate solution. The student filtered off the precipitate and collected the filtrate. Give an ionic equation for the formation of the precipitate. Well, we've got barium chloride solution. It's going to be Ba2 plus SO4 2 minus to form BaSO4, barium sulfate. Ba2 plus SO4 2 minus to form barium sulfate. So we've given an ionic equation for the formation of precipitate. Show by calculation which region is in excess. Well, if you find out the moles of barium chloride and then the moles of sodium sulfate, yeah, that's what we have to do. So it's going to be, it's just going to be moles of barium chloride, BaCl2. Well, moles equal concentration times volume. We're going to use that formula. So it's going to be concentration 6 divided by 1000, because we want it, because this is a mole per dm minus cube, times by 0.25, and we can find out the moles of sodium sulfate, Na2 SO4, 8 out of 1000 times by 0.15. So we get 1.5 times by 10 to the power minus 3, and we get 1.2. Therefore, which one is in excess? It's going to be barium chloride because we have more of it, so it's going to be BaCl2 excess. BaCl2 is a region in excess. And then it says calculate the total volume of the other region, which should be used by the student so that the filtrate only contains one solution. Okay. So it's going to be, the total volume of the other region is going to be 10 centimeters cubed. 10 centimeters cubed of sodium sulfate of 0.15 mole per dm minus 1.15 mole per dm minus cube of sodium sulfate. But it only asks for the total volume, which is 10 centimeters cubed. Question 4.6, 4 marks. Okay. A sample of strontium has a relative atomic mass of 87.7, consists of 3 isotopes. In this sample, the ratio of abundance is 1 to 1. State whether isotopes have identical chemical properties. Calculate the percentage abundance. And yeah, okay, so first things first. Why they have identical chemical properties? Chemical properties is going to be because same electronic configuration. Then it wants me to calculate the percentage abundance of the 88 isotope in the sample. So we've got we know the relative atomic mass is 87.7. Let's get that down. Is equal to over 100 because of percentage. So now we've got this down. Now it makes it easier for us to carry on. So we've got 86 SR. 86 SR to 87 SR is 1 to 1. So let's just treat it as X. So it's going to be not 86 times by 1, 86X plus 87X. Because they both have the same 1 to 1 ratio, so they both are 1 to 1, so both have X's in this case. We're trying to find an 88 isotope, so 88. Well, we've got 2 X's here, 86X and an X here, curly X. So it's going to be 100 minus the 2 curly x's all over 100 is equal to 87.7. So now it's just finding out what x is, and then we can find out the percentage bond of 88SR isotope. So we're going to get 8770, I'll just times by 100, you get 1, 2, is equal to 86 plus 87, 173x, 3x plus 88 times by 100, 8800, 88 times by minus 2, minus 176x. So let's collect the x terms. So 173 minus 176 minus 3x is equal to 8 is equal to minus 30. Therefore x is equal to 10. Negatives cancel out and we divide by 3. So yeah, we could just write this minus 3x equals minus 30, then we get 3x equal 30, then we get x equals 10, which is 10%. So if we're trying to find out percentage of 88SR isotope, well, we know 88SR isotope is 100 minus 2x. So it's going to be 100 minus 2 bracket x 10, 100 minus 80, no, minus 20, which will give us 80. So the final answer is 80%. Pretty hard question for percentage abundance, but it's for 4 marks. So why they have identical chemical properties, same electronic configuration, and then we use algebra 1-to-1 XX 88SR 100 minus 2x, we've got an x here and x here, times by 88 over 100. Move it to the left hand side of 100, and we can find x, and therefore we can substitute x in to find the percentage abundance of 88SR. 4.7, the time of flight mass spectrometer obtained for these 3 isotopes. Identify the ion with the longest time of flight. So obviously going to be this one, it's the heaviest, and be 138 Ba, but because it's an ion, it's going to be a positive charge because ionized by electron impact. It's going to be 138 Ba plus. 4.8, and then that's the final question. Question 4. A 137 Ba plus ion travels through flight tube of time of flight mass spectrometer with kinetic energy of that. Ion takes that long. Calculate length of test tube. Calculate length of flight tube in meters. So we've got the kinetic energy of the ion. We've got the kinetic energy. We've got the time. Do we have the mass? Let's check. Previously, no. We don't have the mass. Okay. So 5 marks. We're gonna work step by step. So we need to find we're trying to find the distance, so we need to find, this is a pretty hard question now, just need to find the first step. We need to find the mass. That's why they gave us Avogadro's constant. That's why. Because we're trying to find the mass. Okay, now it's really easy. The first step was just the hard part. Now we can find the mass of the iron by just doing 137 by 10 to the power minus 3, because we want it in kilograms, over Avogadro's constant, which is 6.022 times by 10 to the power 23. And now we've got the mass. It really is the light work from here. So that gave me 2.27 times by 10 to the power minus 25. Now that is the mass of the iron. What we're trying to find is the length of the flight tube in meters. But now we've got the mass, we can find the velocity, because k is equal to half mv squared, 2ke divided by m is equal to velocity squared. So velocity squared is equal to 2ke, 3.65 times by 10 to the power minus 16, 3.65 times by 10 to the power minus 16 over mass, which we just worked out, 2.27 times by 10 to the power minus 25. And then square root the answer, so we get velocity as 56708. That is the velocity. Now to find the length of the flight tube, well, we know velocity is equal to distance over time, distance, velocity times by time, distance is equal to 56708 times by time, which is 2.71 times by 10 to the power minus 5. Bracket so we don't get confused. And we get 1.5367868, which is 3 significant figures, 1.54 to 3 significant figures. Whew. And that's the end of question 4. So I just want to focus on time of flight mass spectrometry 1. So the hardest part was finding out the mass for me. as soon as you find out the mass of the iron, because iron, find the mass of the iron, this 137 divided by 1000 because we're on kg, divided by Avogadro's constant. There's a reason they put it in, because that will help us find the mass of the iron, divided by 6.022 times by 10 to the power 23, get the mass. Now we've got the mass, because remember, to find out the length, we need the velocity. So now we can find the velocity, rearrange it, so we get 2ke is equal to mv squared, and v squared is equal to 2ke over m. V squared is equal to this, v is equal to square root of that, which I already worked out as this. And now we can quite easily find the distance. So the distance is equal to v times by t. This 56708 times by time, 2.71 times by 10 to the power minus 5, and you get 1.536, so 1.54 meters to 3 significant figures.